For over 10 million years, 3I Atlas drifted to frozen void between stars, a silent wanderer untouched by stellar light. But as it plunges toward our sun, something extraordinary is happening. This ancient interstellar visitor is not following the rules. Its behavior defies decades of comet science, challenging everything astronomers thought they understood about objects from beyond our solar system. Jets point in impossible directions. Chemical signatures appear where they shouldn't. And deep within its core, forces are at work that no model predicted. What is 3I Atlas really doing? And why is it acting like no comet we've ever seen? When 3I Atlas was first detected on July 1st, 2025, astronomers expected a familiar story. Interstellar objects, rare as they are, should follow predictable patterns. They arrive cold and inert, warm gradually as they approach the sun, outgas in expected ways, and then fade as they retreat back into the darkness. But 3I Atlas had other plans. The first anomaly appeared in early September, when the object reached 2.53 astronomical units from the sun. Suddenly, without warning, its brightness exploded. Not a subtle increase, not a gradual warming. A violent surge, nearly 2 full magnitudes brighter than any prediction suggested it should be. Models scrambled to explain it. Dust production calculations fell apart. The numbers didn't make sense. Most comets brighten slowly as solar heating increases. They follow a smooth curve, predictable and well understood. 3I Atlas shattered that curve. Its brightness spike was abrupt, global, and sustained. Week after week, it remained unnaturally bright, as if something deep inside had been switched on, something that refused to turn off. The rotation period, a steady 16.16 hours, should have distributed heat evenly across the surface. That part made sense. But what came next did not. The entire nucleus seemed to awaken at once, not in isolated jets or discrete vents, but across its entire surface. Pressure built uniformly. When it released everywhere. This was not normal outgassing. This was a planetary-scale eruption from an object barely a few kilometers wide. As 3I Atlas raced toward Perihelion on October 29th, the solar energy flux increased by more than 10 billion times compared to its interstellar journey. That kind of shock should trigger predictable responses. Solar radiation should push dust and gas away from the sun. The solar wind should shape the tail into a familiar arc, streaming outward into space. Every comet in history has obeyed this basic law of physics. 3I Atlas does not. Observers tracking the comet notice something impossible. A jet, bright and persistent, pointing directly at the sun, not away from it, toward it, as if gravity and radiation pressure had reversed, as if the rules of the solar system had been rewritten just for this one object. Scientists checked their instruments. They recalibrated. They ran simulations. The sunward jet remained, sharply defined, growing longer even as the rest of the coma began to fade. It bent against the solar wind, defying the very forces that should dominate its motion. The answer, when it emerged, was almost as strange as a phenomenon itself. Magnetism. Not weak, ambient fields, but powerful, localized magnetic structures generated from within the comet itself. Spectroscopy revealed high concentrations of nickel and iron, elements that when exposed to liquid water corrode rapidly into magnetite, one of the most magnetic minerals known. But magnetite alone is not enough. To bend plasma and steer charged particles, the comet would need to generate fields of 30 to 50 nanotesla, sometimes spiking to 300 nanotesla during solar storms. Those are strengths typically associated with planetary magnetospheres, not tiny icy bodies. Yet there it was, visible in every image, unmistakable in every spectrum. The magnetic cocoon twisted the jets into wavy filaments, structures rarely seen in solar system comets. It trapped charged particles, creating pockets of plasma that glowed and pulsed. And it shielded the interior, protecting fragile molecules from the relentless bombardment of cosmic rays and solar radiation. 3I Atlas was not just an inert rock. It was an active, dynamic engine, generating forces from within that shaped its environment in ways no one had anticipated. The chemistry told another disturbing story. Comets from our solar system follow expected ratios. Water dominates. Carbon dioxide appears in moderate amounts. Carbon monoxide, if present at all, shows up in trace quantities. 3I Atlas inverted those expectations. Its carbon dioxide to water ratio approached 8, far beyond anything seen in native comets. Carbon monoxide to water sat at 1.65, a signature of extreme volatility and ongoing chemical reactions. These were not the fingerprints of a dormant iceberg. They were the markers of a body still chemically alive, still processing materials even after billions of years in the cold. Spectral analysis suggested links to carbonaceous chondrites, some of the most primitive materials in the solar system, yet enriched with compounds that should have been destroyed by radiation over such immense timescales. Water existed not just as ice, but locked in minerals, possibly in liquid pockets deep beneath the crust. And organics, complex organics, the kind that form the building blocks of life. By mid-December, as 3I Atlas swung past Earth at a distance of 1.8 astronomical units, astronomers were no longer asking what kind of comet it was. They were asking if it was a comet at all. Its behavior fit no category. Its chemistry matched no known object. Its magnetic properties belonged to a different class of body entirely. Some suggested it might be a fragment of a larger world, blown apart in a distant collision and sent tumbling to the galaxy. Others proposed it could be a hybrid object, part ice, part rock, part metal, forged in the chaotic environment of a young star system and ejected before it could fully form. But no theory fit all the data. Every explanation left gaps. Every model broke down under scrutiny. And then came the most unsettling realization. In March and April 2026, Earth will pass directly through the debris trail left by 3I Atlas during its Perihelion eruption. For the first time in human history, our planet will intercept material from another star system, not as microscopic dust grains caught by chance, but as a deliberate crossing of paths. Scientists are preparing instruments. High-altitude balloons will sample the upper atmosphere. Ground-based spectrometers will analyze particles as they drift down. Researchers will watch for anomalies, chemical signatures, molecular structures that don't belong. If 3I Atlas carries organics, Earth will know. If it harbors the ingredients for life, our atmosphere will capture them. If its chemistry is as strange as its behavior, the evidence will fall from the sky. But there's another question, one that no one wants to ask out loud. If 3I Atlas is not behaving like a natural object, if its magnetic fields and chemical processes are too organized, too persistent, too purposeful, then what else might it be? The data offers no answers, only more mysteries, only deeper questions. 3I Atlas came from the darkness, from a place and time we cannot reach. It traveled for eons, alone and silent, until the sun's light woke something inside. Now, as it hurtles back into the void, it leaves behind a trail of debris, a cloud of uncertainty, and a growing sense that we have witnessed something we were never meant to understand. The encounter is not over. The story is not finished. And 3I Atlas, strange and defiant, continues to break every rule we thought we knew,